So in this case we have to find the lengths x and y in the right triangle below and give our answers correct at 2 places of decimals. So let's figure out what we know. We know we have a right angle here. We know one other angle, that's 55 degrees, and we know we have one side is 12. So whenever we're dealing with one of these problems, the first thing we're going to try and do is label the three sides. So here was the right angle, and the side that faces the right angle, that the right angle is opposite, is always the hypotenuse. So that's the 12. So let's call this h for the hypotenuse. The angle that we're given is this 55-degree angle, so we know that angle, and the side opposite that, I've got an arrow pointing away to the other side. The side opposite that is y, and we'll label that as opposite because it's opposite the known angle. 55 degrees is the angle we know, y is opposite that. So we've got the opposite, we've got the hypotenuse, and that means the third side is going to be the adjacent. So the x is the adjacent side. So now what we have to do, once we've labelled those, is set up trigonometric ratios, and let's decide which letter we want to find first, which side we want to find first. And let's say we go for the opposite first, okay? So let's say we want to go for the opposite first, okay? So that was part A, find the opposite. So the opposite is the one we want, and we know the hypotenuse. Okay, we know the hypotenuse is 12. Okay, so you think now about what are the three ratios: sine theta, cosine theta, and tan of theta. Which one of those involves the opposite and the hypotenuse? Okay, the one that involves the opposite and the hypotenuse is sine of theta. So what we'll do is we'll set up sine of the angle. Okay, it's always sine of an angle. In this case, the angle is 55. So we're going to set up sine of 55 is equal to opposite, which is y, over the hypotenuse, which is 12. So sine is equal to opposite over hypotenuse. That's where that first equation comes from. Now the y is what we want. We have an equation here that includes a fraction. Anytime we have an equation that includes a fraction, this goes back to algebra 1, anytime we have an equation that includes a fraction, we multiply both sides by the bottom of the fraction. So we're going to multiply both sides of the equation by 12, the bottom of the fraction. And that's going to give us 12 sine 55 is equal to, what happens over here is the 12's cancel out, and we're just left with y. Okay, so remember, anytime you have a fraction, the way to get rid of the bottom of the fraction is to multiply everything in the equation by the bottom of the fraction. So 12 sine 55 equals y. We want to get the answer correct at 2 places of decimal, so we're going to go to our calculator. And the first thing we have to do, let's pull this over here to this side a little bit. The first thing we have to do is make sure that the calculator is set up to measure in degrees. So hit mode. And if you look at the third line down, you see my calculator currently is set up for radians. So come on down and move across to degree and press enter on degree. Okay, so now it's set up for degrees. Let's quit out of this screen. So second and mode gives you the quit screen. And then all you do is type in 12 sine 55. 12 sine 55. And that gives you 9.8298. 9.8298 is equal to y, but we wanted that correct to two places of decimals. So let's cut it off after the second place, and we can see that the next digit is a 9. It's going to bump this one up. So correct to 2 places of decimals, y is equal to 9.83. Okay. Right, so that's the first missing side. And now you have a choice. You can use Pythagoras' theorem, because you know this is 12, and you know this is 12 sine 55, or 9.8298. And you can use Pythagoras' theorem to find the third side, but we're actually going to use another trigonometric ratio. So if we do that, we're going to try and find, sorry, something has gone slightly wrong here. We're going to do that. This is B, because we called the first one A. So if we do this now, we want to find the adjacent. Okay, so we find the opposite side. Now we want to find the adjacent, which is x. Again, we know the hypotenuse, we know y, but it's not really a very nice number. It's 9.83. H is a nice number, 12. So we know the hypotenuse. So you think, what ratio sine theta, cosine theta, tan theta uses adjacent and hypotenuse? And it's cosine. So we're going to use cosine of the angle. And the angle is 55. Okay. Now cosine of 55 is equal to, cosine is adjacent over hypotenuse, so x over 12. And just the same as we did before, multiply both sides by 12. Because we have an equation with a fraction in it. Multiply both sides by the bottom. And that gives us 12 cosine 55 is equal to x. And again, at this point we can go to our calculator. That's clear what we've done there. The calculator is going to stay in degree mode, so we don't need to check it again. And we just type in 12 cosine 55 and we get 6.8829. 6.8829 equals x, but correct to 2 decimal places, so draw a little division line after the second decimal place, and we get 6.88. The 2 isn't big enough to push this up, so we get x is equal to 6.88, correct at 2 decimal places. So problems like this take a little bit of time. This video has already been running for 7 minutes. It won't take you so long to do this once you know how to do it yourself, but you do need to take your time initially. So figure out which side you know, which side you're looking for in terms of opposite, adjacent and hypotenuse, and use whichever ratio includes those two sides. Then set up an equation and manipulate the equation until you get the letter you want on its own. Okay? Thank you.